Welcome back, champions. In today's video, we are going to solve questions 21 to 30, step by step, from section 1, cause of kicks. I'll break each question down, explain it in easy to understand language, and show you how to approach these problems like a pro. So make sure you watch till the end, take notes, and practice along with me. Let's get started and make learning fun, simple, and powerful. In this question we need to calculate the BHP reduction when pulling drill pipe dry. That means we are removing the pipe from the well without filling it with mud. When we pull drill pipe dry, mud from the hole is not replacing the pipe volume, so the hydrostatic pressure in the well drops. This drop is called BHP reduction. We will use a simple and practical approach. We use the formula. Pressure drop per foot. After going step by step, we find that pulling this pipe dry causes a BHP reduction of 30 psi. This is crucial, because if this drop is not compensated, it can lead to well control issues like a kick. Here's another scenario. We are pulling out of the well from 10,000 feet, and the first 930 feet of 5-inch drill pipe is pulled wet, meaning no mud is returning to the well. Well data is given. Our task is to calculate the drop in bottom hole pressure caused by this operation. We will use the standard formula for pressure drop per foot while tripping wet. After applying the formula and doing the step-by-step calculation, we find that the BHP drop is 290 psi. This is a significant drop, so always remember, pulling drill pipe without filling the hole can drastically reduce your bottom hole pressure.
In this question, we have a tripping operation. While pulling out of the hole fill pump was stopped, and the complete bottom hole assembly, BHI, was pulled dry. This means no mud was replacing the volume of the BHA, which will cause a reduction in bottom hole pressure. We will apply the formula. After step-by-step calculation we get the answer 156 psi reduction in bottom hole pressure. In this question bottom hole assembly is pulled out wet without filling the hole. Well data is given. To solve this question, we will go step by step to find the correct answer. Follow this easy method along with me, and as we complete the calculation step by step, you will see that the reduction in bottom hole pressure is 176 psi. Let's solve question 25, where we will calculate how many complete stands of drill pipe can be pulled dry before the overbalance of 179 psi is lost in a well drilled to 7,480 feet. Applying the formula step by step we find 5,346 feet of pipe, which equals 57 stands that can be pulled dry before the overbalance is lost. Now let's solve question 26. In this problem, we will calculate how many complete stands can be pulled wet before the 200 psi overbalance is lost, by applying the formula step by step using the given well data. Now applying the formula step by step, we calculate the pipe length as 1,761.69 feet, and dividing by 90 feet per stand gives approximately 19 complete stands that can be pulled wet before the overbalance is lost. We are asked, which cause of a well kick is completely avoidable and results from bad practice by the driller? The correct answer is not keeping the hole full during a trip, because this happens when the driller fails to maintain proper mud levels, which is entirely preventable. What is the first action to take? While drilling with water-based mud, we experience a complete loss of returns, and no mud is visible in the hole. The correct first action is to fill the annulus with water and record the volume added, because this allows us to measure the loss and stabilize the well before taking further steps. What immediate action should be taken? The flow sensor shows a total loss of returns, and the mud level in the annulus cannot be seen. The correct action is to fill the annulus with water or the lightest mud available and record the volume. This is because by doing this, we replace the lost fluid, monitor the well volume accurately, and stabilize the well before taking further corrective measures. Situation where severe losses occurred while drilling, the pumps were stopped, and the well was filled to the top with 150 feet of water, and asks how this affects the bottom hole pressure. With severe losses in the well filled with 150 feet of water, the bottom hole pressure drops by 26.5 psi due to the difference between mud and water density.
Thanks for watching. Don't forget to subscribe for more IWCF learning, and please like, share, and comment on this video.